Hello beautiful people and welcome. In this video I want to go through one, maybe two examples on how to write a polynomial function given roots or given zeros. Now if you're in my class, we did have some of these questions on our pretest. We didn't have a chance to review them in our review week. So I do want to cover it right now so that way when you are practicing for your exam on Monday that you are going to be successful on it. Alright, so when you are writing a polynomial function, they are going to give you roots or zeros. So one thing you need to really watch out for if you have a complex root. So anything with an I, like imaginary I, or if you have a square root of something, they always come in pairs. So this guy right here is a positive version, so in the middle. We need to write its conjugate. Now a conjugate means you copy it down, the first term and the last term, and the only difference is you're going to change the symbol in the middle. That is called a conjugate. Now, once you're here, you are going to, what I like to do is create a table. So here are our roots. We got a -2, we got a 0, we got a 2 plus root 10, and its conjugate, 2 minus root 10. From here, we are going to write out x minus for each root. Now don't worry about what goes into x minus just yet, just simply write x minus. I'm going to get up just for a quick moment to turn on the lights back on. Alright, so for each one underneath each root, write an x minus. After that, you're going to go back in and you're going to write another parentheses. Now in the one that's colored blue right now, you're going to take each root and you're going to copy it inside. So here's -2, here's 0, here's 2 plus root 10, I got to do that really small, and 2 minus root 10. So you're writing all of that inside that blue parentheses. I call it bubbles. Now you're going to simplify. If it's just numbers, here's a plus, here's nothing. I mean, x minus 0 is just x. However, for complex and imaginary, so anything with a square root or an I, you're going to take your symbol and you're going to distribute it inside into both of your terms if you have two terms. So we have, this one comes out to x plus 2. This one comes out to just x. This one comes out to x minus 2 minus root 10. And this one comes out to x minus 2 plus root 10. I'm going to rearrange this. I have x first, then I have an x plus 2, then I have my x minus 2 root. Oh, you guys can't see it. I apologize for that. 2 minus root 10. Let's write that a little bit better because it looks too close to each other. And we have x minus 2 plus root 10. These right here, these are your polynomial function in factored form. You don't have to multiply anything out. So this is in factored form. Now in my class, I am going to tell you this, I am going to ask for factored form. Unfortunately, we are limited in the time we have in our class in order to test for all questions, so I am going to ask you to stop in factored form. Please make sure that you know how to expand it. However, for our test on Monday, I'm only going to ask you to do factored form. Let's do another example. So here are our zeros. We got a -4, a -1, a 3i, and a 2 plus root 6. First thing I need you to do is identify your imaginaries and your square roots. So we have an I that has a conjugate. we have something with a square root that has a conjugate. So that means 3i comes with a negative 3i. Otherwise, it can't exist. 2 plus square root of 6 comes with 2 minus square root of 6. Otherwise, the original can't exist. So what we really have for our roots, or zeros, are negative 4, negative 1, 3i, negative 3i, 2 plus square root of 6, and 2 minus square root of 6. Working on the same steps we did last time, we are going to do a little table here, and you're going to write out, actually I could do it right underneath, that's okay. We're going to write out all of our roots or our zeros. I should do these a little bit bigger, but that's okay. 3i minus 3i, just trying to save space here. And we have 2 plus root 6 and 2 minus root 6. Don't forget those conjugates. From here, we're going to do our x minus for each step, for each root. Inside, we're going to create another parentheses. Then you're going to take your 0 and you're going to write it inside. So in this case, it's the light blue one. Now parentheses are important because otherwise you're going to forget to distribute that negative when you need to. So let's go ahead and continue. We got 2 negatives make a positive, 2 negatives make a positive. This one is just a minus. This one's 2 negatives make a positive. This one needs to be distributed. Okay, so let's go ahead and bring stuff down. So we got an x plus 4. We got a x plus 1. Now we have an x minus 3i. We have an x plus 3i. We have a, I'm probably going to run out of space here. That's okay. We have a x minus 2 minus root 6. And I did run out of space. I'm going to write it underneath. We have an x minus 2 plus root 6. So set it equal to p of x because we do want an equation. So equation means there is an equal sign. And then we box everything up. Again, this is your answer in factored form. If, however, they are asking you to write it in expanded form, then you can use the box method to multiply things out. For my class, we are just asking you to write these out in factored form. All right, beautiful people, thank you so much for watching. Bye.